Testing sound. Testing sound. Too much setup work. So as you can see, I've been doing a bunch of fiddling. Um, I took out the address sanitizers, partly because I have my own personal CMake configuration that has debug type that has the address sanitizers built in already. So I just skipped them. Um, and I then decided, heck, I should be turning on all warnings. Discovered that there's a whole ton of unused parameter warnings that I don't want to fix right now. And now I'm tracking down why this one last warning exists. Um, so, uh, and it seems like it might be an important warning. Um, the other thing that I did offline is, you know, why the heck did this change make a difference? Because it's very weird. Why should it make it? Why should it make a difference? Why should it, uh, like, why should moving this initialization from here to here change anything? Why should the extra move change anything? It shouldn't. It should be just fine. And I figured out what it was. Um, on the original, if I took these parentheses and replaced them with braces, then it would be what the original said. The minute in the original version, when this part was over here, the minute I replaced the braces with parentheses, it worked with an explicit initialization. So what was happening was there is an initializer list. Oh, hello there, Mr. Elfman, or Sir Elfman, not Mr. It's very important. uh, I fixed the bug from a while back, the segment fault, and it had to do with initialization lists. Um, and I still don't know why calling the initialization list constructor caused the problem. This was an attempt to catch the whatever problem that might have happened, but this assert never fired. And so I'm not completely sure what went wrong. Uh, I am getting some clang tidy warnings. Yes. Uh, but they show up basically as little orange things that I haven't been paying as much attention to as I should. I should have looked at the clang tidy warning there. Um, and here it says that I should be doing something, and maybe that's what I should be doing. Um, I probably should be doing that. Yeah, maybe I should do that too. What I did do is in this file, I turned on a whole bunch of warnings. Um, so, and now I'm trying to track down why this warning happened, um, which seems a little weird. Like, why am I not using this variable? Uh, oh, yeah. Why? Oh, result underscore. Oh, I have to go through the effort of finding what name this is. Um, here. Okay, what's in fdecal? That's not helpful. That's not helpful either. There we go. Oh, okay. Identifiers do contain a pointer to the thing, the statement list in which they are in. Okay. Okay. So that works. Then I can do this. Um, yep, that's what I want. Oh, that's pretty nifty. I do not even compile to object code, as you can tell from this. I execute the AST directly. Um, I that's a tricky. I've never actually done. I've done something that have been very minimal parsers before, um, and so I had some idea what to do, but I've never actually written anything that translated the AST into a object code of any kind, and that is uh, an interesting and tricky thing to do. Um, and I'm not doing the best tracking of housekeeping information to do even good, uh, produce good error messages on parse failures. Uh, though honestly, actually, it's completely different information that you have to track in order to produce a decent stack trace when something goes wrong in the actual running program. And I do actually capture that information because that's just it. You have to in order to have it run at all. And the fact that I'm running directly out of the AST means that everything is all directly connected to parts of the code already anyway. Of course, that won't catch out of bound pointers that happen to point at mapped memory that is simply not part of the object that you're trying to access. But, uh, you know, it's the reason why C is so fast. And C++. Let's see here. Okay, so I fixed that warning. And now we're going to ninja clean and then try rebuilding it all. And if things go well, no warnings should pop out. I should have fixed them all. Oh, that works. Yes, and it avoids any branches. So the branch predictor, uh, yeah, it avoids any branches and therefore any pipeline stalls. And also has a lot less load on the branch predictor because the branch predictor isn't trying to predict any branches. Yeah, makes sense. Um, and all the tests pass, and the sanitizer doesn't trigger, and debug slow is the version where the sanitizer runs. I made my own CMake target here. Yeah, basically, I wrote a whole bunch of CMake, partly to clean up how I'm setting the flags. Before, I was setting flags in a really ugly way, um, because I had the flags that I wanted to use for the various things, not the flags that it wanted to use. In particular, I use March native and M2 native for everything. Uh, maybe I should do that for regular old debug as well. But I rarely make memory errors. This one was made by accident, only because for some reason the initializer list and constructor was being called, and I don't know what side effect that was having that was eventually causing a memory corruption bug. But that is what was happening. And had that not been the case, I wouldn't have had a memory corruption bug. And that's I guess that's a subtle thing. It's an unusual situation. But I rarely write them. I'm very careful and disciplined about how I write programs and very rarely have that kind of thing happen. One thing I do with all of my programs before I release them is I do run a full test suite through Valgrind, for example, which is more rigorous than most Andrus sanitizers are. But yeah, it's also slightly less rigorous because it has less internal knowledge about the program than an address sanitizer or undefined behavior sanitizer does. But I have this debug slow target now, and that's sort of a way to run all the sanitizers. So if that's what I want to do, I can do it. That's not what I want to do. I don't have to. The other thing debug slow does is -O0 instead of -OG, which is what I was using before. -OG has the unfortunate side effect of sometimes optimizing away things that I really want to see when I'm debugging. So let's look. What did I change here? This is also going to be kind of cut short because I have something I have to do in about half an hour. What's F2C? Oh, I did fix a bug. This would have been a memory corruption bug. And yeah, this is a result of an AI, letting an AI do things. I shouldn't have let the AI come up with my loop for me like this. Or I should have been more careful about monitoring what it was doing. Looked good, but no, not greater than or equal to 0. Frame will never be negative because it's an unsigned. And the warning caught that, which is great. And so, the warning caught that, oh, this is always going to be true because frame is unsigned. It's like, oh, that's not good. So I went through and fixed the loop. Um, and this is just fine. Um, this will work great. uh, could have made it a do while loop instead. Um, but I think that would have just confused people. I think a lot of people may not even realize that do while loops exist in C++. There we go. Hmm. Oh, that's an interesting idea. I I don't know. I have a set of rules for myself about things. I avoid the use of bare pointers like the plague. I try hard to almost never use them. And if I do use them, I use them in very controlled ways, and think very hard about using them. Although, of course, one of the bugs that I had was because I had a bare pointer I shouldn't have. Um, and it was one that I didn't pay attention to because it's lifetime. In fact, that's what this whole for loop with the frame that I just fixed was for. Oh, stupid thing and its inability to handle focus follows mouse. There you go. This one, this bug. This used to be using reverse find, and then I would return directly the address of the stack frame. Um, and one of the problems is as soon as anything is pushed onto the stack or popped from the stack, well, that address of the stack frame is going to might change because the stack might move because it's a vector. And well, that's not acceptable. Uh, so what I did, and the reason why I didn't think about it was because, well, the result of find identifier is supposed to be used almost immediately. But in fact, there are several cases in which I call find identifier and then I do the visit for the sub expression or whatever. And that might actually contain a statement list, which is another scope, which might cause something to be put onto the stack frame. It looks like it's being used right away, but it's not really being used right away. And so it was a concern. And so instead, I started returning the index of the stack frame. Um, so that was a memory error that didn't get triggered by anything. Um, but it was just sitting there waiting. And I found it while trying to hunt down why, because the problem that showed up was that the memory that catch 2 was using was being corrupted. And the only way, catch 2 is having some kind of pointer problem. And it's like, that's not a problem in catch 2. That's a problem in my code writing over something it shouldn't write over. Um, and so I, by inspection, found this problem um, and fixed it, but it wasn't actually the problem. Instead, it was this other subtle thing involving an initializer list that I don't understand why it caused a problem at all. So, yeah. I did make a stab at using the new C++26 uh, syntax for asserts and contracts, but that's not yet supported. And one of the weird things is it looks like a label, and so it compiles just fine. You can do this, right? And then you put in your whatever your assert is, your and that gets turned into like the contract assert um, in C++26. You can also put in pre something uh, and post something here after a function definition declaration, but before the opening brace to have preconditions and postconditions for your function. Um, and that, of course, won't compile properly in a non C++26 compiler. There's actually some really fancy things about selectively turning them off or turning on reporting that the assert failed without actually having the program fail, or uh, and also the standard is written to handle linking issues with linking with code that was compiled with assertions on versus assertions off. It's a it's actually a pretty well thought out standard that they put together here, and the uh, invasion into C++ syntax is in fact fairly minimal. Um, they spent a long time hashing it out. I saw some presentations at CPPCon 2024 about it, And then it was a much more complicated proposal. They whittled it down and made it a lot simpler since I saw that presentation. So anyway, uh, now that we have all this working, I'm not quite sure what the next thing I want to do is. Oh, well, I know what the next thing I need to do is. Now that I have function declarations working, I have to implement function calls, and I also have to uh, actually try to call the function. Do I ever call the function declaration function parser? I don't think I do. Nope, I don't call them. That's okay. Um, so now I'm going to try to parse a function call. And that's the first thing. And that's the next thing. I got that right too. Uh, yep. All right. And indeed, this is what I want. Sorry, that's what I want here. Okay. Is this what I want next? I do want that check. I want to check whether there's an open paren. Indeed. And so if there's not, then I return, yep, that's correct. Okay. Now, oh, okay. This is wrong. This is right, but this is wrong. I'll have to check out F2C, by the way. Because if I don't see a comma, it might just be fine. I should break from the loop if I don't see a comma. So start equals next start. Yep. Expr, comma remainder. Huh. This bind syntax doesn't work when, oh, how annoying. How annoying. because I want to rebind the value of this expert, right? Um, Here's what I can do. Like this, semicolon. Oh, except whiles don't allow semicolons here. So I can do for instead. Okay. Do whiles? No, no, whiles wouldn't allow semicolons. So that's fine. And then our move to the next is just the only problem is then okay. So here, start equals remainder. Yes. This is how I want to format this. This is off at column 73. That's fine. One of the things I don't like, I mean, these are helpful here that Sea Lion puts in. They're kind of nice, except for the fact that uh, they obscure whether a line goes past 80 or not. And that's a formatting thing I care a lot about. Maybe I could fiddle with Sea Lion to get it to still tell me about lines that are longer than 80 columns somehow. Uh, but not over here, because over here it's everything's just a little too subtle for me to notice, to pay attention to over here. Okay. So as long as we have an expr, then args dot in place back, start equals remainder. Oh, there's a problem though. Nope, this is not going to work. Okay. Okay. While expr. That's great. There we break if we didn't see a comma. If we did see a comma, we move past it. Then we try to parse the next expression. But here, if the expression happens to be null, but I don't want to create a shadow for a remainder. So after expr, then, yep, that's what I want. Oh, how ugly, but it works. That works. That should work. So If I don't see a comma, then I just break. If I do see a comma, then I grab the next expression. Um, and now, here I don't care about if it's not a closed paren, yes. But also, I should double, this is probably a redundant check at this point, but I'm going to put it in anyway. This is a very repeating pattern, and I should encapsulate this repeating pattern somehow. And oh, I don't know if you saw the spam, Mr. Elfman or Sir Elfman, but I really hate the spammer from this one. And it's always this one particular website, which tells me that I should never, ever use this website because they're incredibly disreputable. I mean, you'd think that Twitch could look for the name of that website and just ban all mentions of that website, because what that website is offering to do is also should be is against Twitch's terms of service. Um, so yes, but apparently that's just too hard for them to do. Okay, so there is the func call. So now what we're going to do, return, make unique, function call. No, why are you doing that? What made you put func? And it's not ID. Um, where did I get the name of the function from? I believe it's here. Okay, so what does the func call constructor look like? It needs an identifier. Ah, this is an identifier. Oh, an identifier is a scope and an index. Oh, there's one other thing about it. Um, okay, there's something I missed doing up here. Parse func call. There's one other check. Oh, this is an identifier token. That's right. So then we have parse identifier. How does parse identifier work down here? Aha. This is exactly what I wanted. This is, okay. I shouldn't have done this. What I should have done is, yep, yes. Nope, this should remain an assert because this is basically something that is absolutely required uh, for uh, parse identifier. Parse identifier has no business not returning an identifier. Um, all right. And I don't want to remember this. This is a, this is interesting. So there is another problem here. Okay. So the scope is a statement list. Statement lists have var declarations. Don't you know that this is a statement list? Yes. And this statement list has var declarations, but somehow you are not realizing that and I do have an identifier. There's var IDX, right? Yeah. Why are you not discovering that I have these things in here? Like, so var info. Now, what is var info? Oh, yes, there. So if we've just got an identifier that's not an identifier for a function, in other words, the type of our identifier is wrong, um, then that's also a parser. And I don't have to say start equals standard next start because start should just equal remainder. All right. Now, so function calls, what do they consist of? So our func name, which right, func name is in fact, and then args. Yeah, yeah, that's exactly. Why does it not want to? Okay, func name. What is the type of func name? Func name is an identifier constant reference, right? Identifiers. Oh, no. So identifiers are copyable, right? Because they have two things. They're copyable, they're movable, they're all kinds of things. So this should work just great. So let's see, is func name like shadowed? But it shouldn't be, right? And then down here, make unique func call, right? And then func call, func name. Okay, I'm going to build this and discover whether the compiler thinks it's a compile error. Okay, so yes. I'm gonna have to come up with different names for these. So make unique func call. I need to find an initializer for, this is the dot func, which is an identifier, right? And so I need to initialize it with an identifier. And the next is a vector of AST pointers, which is args. Yes. What's wrong? What is wrong with this? Oh, no. These should be the constructors to func call. Okay, how am I doing these make uniques in other places, right? Oh, that's the reason why I can't do that. It has to be a make unique AST node. And then here I have to say, oh, this AST node contains a func call there, like that. Okay, that's better. Okay, that works. Now let's try it. Huh, it won't let me initialize an identifier in this way. Why not? Right? Why won't it? If I make this not a const reference, is it like that better? No? Huh. Anyway, I have to leave now. I am sorry. I'll probably solve this offline. And this is an obnoxious kind of vexing problem. I'm not, I'm confused as to why this is not working. Anyway, um, yep, it was nice chatting with you too. Thanks for showing up.